Hi guys, this is Achut. So we are going to be solving today's LeetCode question, which is cheapest flights with K stops. Here we are given n cities, and then we are given some of the flights, which will be starting from some of the city, like from I, and then it will reach to the city called to I with the price I. So these flights indicate from which city it is going till which city, like from and to, and there will be some price attached to that flight from source to destination. So what we need to find is we need to find the cheapest price we can go from source to destination. So let's say there is one source and then there is one more destination. We need to find the cheapest price we can go from source to destination using the different flights. It can be different flights. You can go from I to J and then J to K. So it's and then K to destination. So this can be different paths. By using these paths, there should be at most K stops. At most K stops means it cannot be more than K stops. Let's take this particular example. Here we are given that we have n cities. N is 4. So which means there will be 4 cities 0, 1, 2, 3. So these are the 4 cities. And then we are given the flights which includes these flights. These are the this indicates the flight, and then this this flight this flight will take 100 price to go from city 0 to city 1, and then from 1 to 3 it will take 600 price. So we need to find the cheapest price we can the cheapest price which we can get from source to destination using K stops. Let's say here K stops is only one. That means 0 is the source and then 3 is the destination. These are the source and destination. In between these two stops, there, mu- there must be at least, there must be, it should be less than or equal, it should be less than or equal to one particular stop. So that is the condition for this. It cannot go more than uh, one stop, like the K stops. So as it is given that K equal to 1, it cannot go more than K. So that is a question. Suppose consider this particular example only, and then now there can be multiple paths. It can go from 0 to 1 and then 1 to 3. This is one particular path. And then one more path to reach 3 is 0 to 1 and then 1 to 2 and then 2 to 3. So this is the second path. So out of these two paths, this path will take only one stop, and then for this path it will take two stops. The in between stops will be two stops. So we cannot consider this particular path. Why? Because it contains more than one stop. So it should not contain more than one stop. So we'll consider this particular path, and then we are going to return this particular answer, which is 100 and then 600. So this is the question. So we'll be using the DFS for this particular solution. So here we'll take the adjacency list, and then here we'll add the adjacent cities which are adjacent to particular city. Let's say we'll start from flight 0. We can reach to flight 1 with the price of flight 2, as it contains like from, to, and then price. We are adding from this particular flight. What are the cities which we can travel, and then with the prices. And then we have one more vector which will store the price it will take to reach that particular city within k within k stops. Suppose let's take one more queue so that it will store all the cities whichever present in our particular queue, and then we'll be popping the elements which are present in the queue, and then we'll be visiting the each city. So for this particular case, first we'll start with the source. So for the source, as we are in the source, the price taken to reach the source will be 0. Why? Because we doesn't require any price to travel from source to source. So that will be 0. And then we'll be pushing into the cities. And then we'll be doing the DFS traversal for this particular case. So until the cities is not empty, and then stops is always less than or equal to k, then we are going to do this particular operations. Those operations we'll see. So let's say this is the this is the uh, this is the source, and then we'll go through as cities is not empty as it contains this particular source. So we'll take the size, whatever the size. Here it is only one, so it doesn't matter. But in some other cases we'll get 2, 3. At that particular cases we'll get to know why we are taking size. So this particular case we are taking size equal to 1, and then for this particular case, the city is going to be current city, and then price, whatever the price required to reach this particular city is going to be the current price. And then for this particular city, there can be different cities which are neighbors. Suppose let's say for this city, the neighbor city is 1. Why? Because it contains a directed edge from 0 to 1. So we'll visit all the neighbor cities, and we'll see whether this particular case, if we consider this particular case, this distance whichever we got from 100 plus 0, this will be 0 initially. So 0 plus 100 is 100, and then as we are assigning all the distances, all the price equal to int max, so it will be less than it will be less it will be less than the price to reach city. So we'll be coming here, and then we'll be assigning the price to reach this particular city is going to be whatever the current price for this particular city, and then the next city is going to be this, and then for moving from current city to next city it is going to take next price. So we are adding to that price, and then as we are saying that this is the neighboring city, and then it contains the less price if we consider this particular path. So we are pushing into the cities queue, and then after this there will be this particular city, and then we'll be popping the zeroth city. Why? Because it all the cities which are neighbor to 0 are visited, and then we are going to pop this city, and then we are going to take one more loop, and then stops will be incremented. Why? Because the stop increased to 1. Why? Because this has been reached. So and then we'll come back again. For this particular case, cities is going to be only 1. Why? Because it contains only 1. And then for this it is going to consider all the city prices, all the neighboring cities, which is 2 and 3. So this particular 2 and 3, it is going to consider 2, and then for this 2 we'll check whether this particular path is less than the whatever price to reach city. It will be lesser, so we'll be taking this particular price is going to be 200 to reach this city, and then again it will come to this particular path, and then again it will see what is the price required. So the price required will be 100 plus 600, so it is going to be 700. The price to reach the city is going to be 700, and then it will increment stops to stops plus plus, which will become 2. So as 2 is greater than 1, so it will come out of the loop, and then we'll see what is the price to reach this particular city. So if it is int maximum, then we can say that we cannot reach that particular city. So it is going to return -1. And if we can reach that particular city, then we can say the price to reach city is going to be this particular price. Yeah, let's run this and then see. Yeah, let's submit this. So here we are just taking the adjacent element, and then here we are taking the price, which is going to be, which is the distance. And then for all the cities which are currently in the queue, for those particular stops, we are going to visit all the neighboring elements, and then we are going to consider this particular condition. Based on this condition, we'll do the operation. After that, at last, we'll see whether we have the path to reach that particular destination or not. If there is a path, then we are going to return whatever the price which we got from this. And then if there is no path, then we are going to return -1. Yeah, thanks for watching.